Hi. In this session, we are going to cover the third reaction of the electrophilic substitution reaction series, and the name of the reaction is halogenation. Now, before understanding the reaction, let us first understand the term halogen. Maybe you have heard of this term. So, this term is actually designating the 17th column of periodic table. Over here you can see the periodic table, and there are a lot of columns in the periodic table. The number is 18. The total number is 18. If you go to the column number 17, these group of elements are called halogens. The elements include fluorine, chlorine, bromine, iodine, and there are two more which are with the name astatine and tennessine. So these 6 atoms are called the halogens. Okay. So the reaction which we are dealing with, the halogenation, it refers that any of the halogen of this family is going to replace the hydrogen of the benzene and would be replacing the hydrogen atom. So for example, if it is chlorine, then X would be Cl. So this would be called chlorobenzene. If it is bromine, then it would be called bromobenzene. So the reaction would be called bromination. And if it is iodine, then the product would be called iodobenzene and the reaction would be called iodination. Now, one important thing to note here is the reaction is being catalyzed in absence of light. This is one important statement here. The reason is this: if you carry out the reaction in presence of light, then the reaction is not substitution, instead it is addition. As you can see that in presence of light, the chlorine reagent is being added across the 3 pi bonds of the benzene ring, and it is giving us the addition product. So double bonds are missing and chlorine atom has been added to each carbon. So the product is called benzene hexachloride. We will discuss about this reaction in detail in the further lessons because it is one of the products that we have to study, this benzene hexachloride. Let us now go back to the halogenation reaction under the electrophilic substitution. So I was stating that this mention that absence of light is very important, because if in presence of light this reaction is carried out, this would become an addition reaction. Only in the absence of light this will be called the substitution reaction. Only then hydrogen atom would be replaced and the halogen atom would be introduced. Another thing which is being used here is Lewis acid. Now this is the first time that Lewis acid concept is being taught to you under this subject. So previously we have seen nitration and sulfonation. In those cases we were using acids as the catalyst, and the acids were Arrhenius acids. There are 3 definitions of acids. One is Arrhenius acid, the other one is Bronsted acid, and the third one is Lewis acid. So these acids, H2SO4, which were previously used as a catalyst, were Arrhenius acids. For the first time you are seeing a name Lewis acid, and these Lewis acid are the third category of acids in which states that anything which can accept electron can act as acid. This definition was given by Lewis. So such type of acids which act as an acid by accepting the proton are called Lewis acids. So usually the metals which can accept electrons because they have vacant orbitals act as Lewis acid. The examples are aluminum trichloride, iron trichloride, boron trifluoride, and zinc dichloride. So these are the examples of Lewis acids. As you can see, these are the molecules which belongs to metal series or maybe alkali earth metals. So these are the ones which acts as Lewis acids. Okay. So in our reaction, we are using a Lewis acid. The Lewis acid can be anhydrous ferric chloride or anhydrous aluminum chloride. So let us directly jump to the practical reaction. We are performing chlorination of benzene. So in this case, we are going to use chlorine and the product would be chlorobenzene. We are going to do this reaction in absence of light but presence of heat, and the Lewis acid, which is ferric chloride. So let us see how the reaction will proceed. The first step is going to be generation of electrophile. So chlorine molecule is going to get in contact with Lewis acid, which is iron trichloride here. So what will happen? The lone pair of the chlorine atom will be donated to the iron atom because it is going to act as a Lewis acid. It is accepting the electrons. This is the property of Lewis acid. and this is going to act as a Lewis base. Definitely it is acting as Lewis base. So a bond will be found between the chlorine atom and the iron atom, and a positive charge would be placed over chlorine because the lone pair has been utilized to form a bond with iron. So positive charge over chlorine and negative charge over iron because it has accepted a lone pair. Okay, so our complex would form, and this complex will dissociate such a way that the chlorine bond would be broken such that positive charge on one chlorine would be neutralized, and this chlorine will be removed as a Cl positive ion. This is called chloronium ion. Okay, it is the electrophile of our reaction, and the other species which was formed was FeCl4 anion. FeCl4 negative. Okay, this was the first step, that was the generation of the electrophile. In the second step, our benzene molecule is going to attack on the electrophile. This is going to be a slow step, and resonance structure of the carbonium ion will form. And in the last step, the carbonium ion or the carbocation will lose a proton, and this will be assisted by the FeCl4 negative which was previously generated, and this hydrogen will be removed as a proton, and the 2 electrons would be shifted back to the benzene ring, regenerating its aromaticity. And the step is going to be a fast step, and the final product will be chlorobenzene, and the catalyst would be regenerated and HCl would be formed as a byproduct. So this was the chlorination reaction. We have studied what halogenation reactions are as a collective term. There are chlorination, bromination and iodination under this category. We have discussed chlorination. Chlorination can be used to study the bromination also. You simply have to replace the Cl with bromine. So everything would be same. So chlorination, bromination could be understood very well by studying the chlorination that you have just studied. Iodination need to be studied, which is the leftover topic. We will discuss it in next session. So that's it for this session. In the next session we are going to cover iodination of benzene.